Good morning. Welcome back in second lecture of viscosity. Today we discuss about the various concepts of viscosity. Streamline flow, turbulent flow. What about the nature of streamline flow, critical velocity, turbulent flow nature of the fluid, and so on. Again, Sanjeevanee Mahavidyalaya Chapoli, affiliated to Swami Ramanand Tirth Marathwada University, welcomes to you. Viscosity. Already in first lecture I have told you, viscosity is nothing but a quantity which retards the motion of the adjacent layers, or we say it is nothing but a resistance offered by the slower layer of the liquid or fluid on the faster layer. So viscosity is nothing but a quantity which resists the motion or flow of the layers of the liquid. Again, more viscous liquid or fluid is said to be thick, and lower viscous liquid is said to be thin. In last lecture we have seen grease and engine oil. If we compare, the grease is thick than the engine oil. If we compare grease with water, surely water is thin than grease. So grease is thick, water is thin. In this way, the fluid having more density are said to be thick, and having low density are said to be thin. So more fundamental approach to viscosity shows it is a property of a fluid, relates applied stress to resulting strain rate. So here consider the fluid shared between two plates, in which bottom plate is fixed and top plate is what? Moving at constant velocity v in positive x direction only. Then u is nothing but u of y only. Geometry dictates that shear stress T of xy must be constant throughout the fluid. Now let us turn towards the streamlines. What are streamlines? Streamlines are defined as path taken by particles of fluid under steady flow conditions. If we represent the flow lines as the curves, then the tangent at any point on the curve gives the direction of the fluid. Direction of the fluid velocity at that point is shown in figure below. I will show you bigger figure, and in this figure you will come to know that how tangent at any point on the curve gives the direction of the fluid. See here, this point is taken here, and here if tangent is drawn to this curve at point this, and here also tangent is drawn at this point on this curve streamlines, then v1 and v2, what are these? These are the directions of velocity of the fluid at these particular points. So these tangents at these 2 points shows the velocities of these points of the streamline. Yes, points shown in figure below. See here, carefully observe. Suppose this fluid is flowing like this in a line. different layers have different lines and they move parallel to each other. Such a flow of fluid is said to be laminar flow, or it is also called as what? Streamline flow. If the velocity of this flow is increased to a certain value, then what happens in figure B you see? Here fluid is going to flow and here velocity is going to increase. Here velocity is increasing and at a certain velocity of the fluid, here velocity is what more and the parallel lines are removed. I mean there is a mixing of the layers of the fluid after certain velocity. That velocity is said to be what? Critical velocity. I mean the velocity of the fluid from laminar flow to turbulent flow. When turbulent flow begins from a certain velocity, that is said to be critical velocity. Remember, in turbulent flow what happens? The parallel lines of the fluid, they mix with each other. There is a zigzag flow of the molecules of the fluid. Here you see, there are two plates. One plate is fixed and the other one is what? Moving. Suppose the height of this liquid from fixed layer to the moving layer is suppose y. Then shearing stress tau is nothing but force upon area. Shearing stress is proportional to velocity gradient. See here, v is velocity of the fluid. If we think about these layers, suppose this is first layer, this is second layer, third layer, fourth layer, fifth layer, and so on. But this layer is adjacent to the fixed layer. So its velocity is less. Velocity goes on increasing as we go above. As we go above a certain height, up to a certain height, here you will get maximum flow of the layer. You might have observed the effect. You might have observed while watering to the soil by canal. Then what happens? The layer of the water in contact with the soil moves slowly, and the upper layer what happens? Moves fast. I mean these layers move fast. I mean they pass one another. In the same way, here velocity of this upper layer is more as compared to its adjacent, and it's again velocity decreases as we move toward the fixed. So in this way, tau is equal to f upon a is equal to mu into dv by dy. Velocity gradient. So mu is a dynamic viscosity coefficient of the fluid. This can be explained with the help of this figure. Suppose this is a fixed layer and this is a what? Upper layer. The fluid is a viscous and its last layer from the fixed layer is up to height h. This is apparent velocity profile. Here, perform the experiment for all common fluids. Applied shears is unique function of strain rate for a given V. Txy is constant. It follows that du by dy, here du by dy, that is exy are constant, so that the resulting velocity profile is linear across the plates. So these are the two plates, fixed one and this is what? Moving one, and surely the velocity of this plate is what? More. As we go from bottom to top, velocity is gradually, velocity of the layers what happens? Increases. Fluid dynamic or shear viscosity formula. Mu is equal to Fy upon Au, where mu is dynamic viscosity measured Newton second per meter square. F is applied force in Newton. Separation distance in meter. How much they are separated, that distance is y. Sometimes it is given by letter h also. A is nothing but area of each plate in square meter, and U stands for what? Speed in meter per second. So in this way, fluid dynamics or shear viscosity formula is nothing but mu is equal to Fy upon A. Remember what is F, what is Y, what is A, what is A, all these things. Now here picture clears. There is a Reynolds number. What is its significance? What it is? All these things we discuss. Here velocity is going to increase as we go higher and higher up to higher height, or from bottom to top. In this case, suppose this is length. Reynolds number Re is nothing but ratio of inertia force to viscous force. So it is given by symbolic representation rho VL upon mu. Reynolds number is dimensionless because it is a ratio of force. So Reynolds number is nothing but VL upon V. So with kinematic viscosity V minus V, it is equal to mu upon rho. Here Reynolds number per foot is nothing but V upon V. Now let us turn towards the concept of streamline flow. Before Newtonian oil is nothing but it gives the relationship between fluid stress and strain. Coefficient of viscosity of Newtonian fluid is measured in terms of Newton second per meter square. Thermodynamics property that varies with T and P. Already I have told you viscosity depends upon temperature and excess pressure, extreme pressure on the fluid. Streamline flow in fluids is defined as the flow in which the fluids flow in parallel layers such that there is no disruption or intermixing of the layers. Layers are not going to mix with each other. They are moved parallel to each other. Such a flow is said to be what? Streamline flow. The velocity of each fluid particle passing by remains constant with time. Here, at low fluid velocity, there are no turbulent velocity fluctuations, and fluid tends to flow without lateral mixing. Here, the motion of the particles of the liquid follows a particular order with respect to the particles moving in a straight line parallel to the wall of the pipe, such that the adjacent layers slide past each other like playing cards. To understand the liquid flow pattern better, I will give you the links to you. So you try to understand with the help of figure. These are the parallel layers. So we say that this is a streamline flow of liquid because there are parallel lines of the parallel lines shows what? The layers of the fluid, they move without mixing, without intermixing with each other. So that we say this flow is said to be streamline flow. This image shows the curve describe how fluid particles move with respect to time. The curve provides a map for the flow of this fluid for a steady flow. This map is a stationary with time. In this way, we can say that streamlines in a laminar flow follow the equation of continuity. AV is equals to what? Constant. And in last lecture we have seen whenever reducer is also applied to the pipe, then also area of cross section into velocity is equals to the area of cross section of the reduced pipe into the velocity of the fluid. They are what? Equal in nature. So we have already seen the continuity equation. When the area of cross section is greater, the velocity of the liquid is lesser and vice versa. This also we have seen